Yeah, but you never have
We're live streaming this,
positive
so derive this new equation.
Mr. Newfeller, you're supposed to read a question too?
Yep, 1, 2, 3, 4. Number them, show the calculation.
Okay, yep. So
Can you tell me what that is? Like this.
and then 10 to the power of negative 4.
Oh, I don't know what you get. Just that one. That's all you have to do.
Oh, and then we have this. Yeah, pH plus 2. Is that right? This?
Yeah, pH has to 12.
Okay, that's pretty high number, but sure. This should.
Put it as a.
What's this?
12. Yes.
Oh, actually.
No, I did the totally wrong one. That's fine.
Now, just, the only thing I'd say, if you're completely done, double check your sig figs. We haven't formally done sig figs in these days, but I've sort of told you about them several times.
So the pH has 2 digits after the decimal, then would it be 2?
Yep.
Yes, 14 minus.
We have
That is wrong.
We're not done. pH is different sig
No, hold it.
So, wait, do you have the relations?
For number 2, 0.006 molar, we have 2.22. And then,
They're very weird. Okay. For the first one,
What about number 2? Not, no, I guess you gotta sit down. Number 2.
get
That's
on there.
0.006.
all wrong or all
I like how you just start up. They're all wrong.
All wrong.
They're all wrong. They're all wrong or incorrect. You're looking good. First one was 4. That's good. 2.2 is good. The last one,
Okay, that if there's a 0.
number 4, asked you to calculate from the concentration of OH minus. And it looks like you have. We want the pH, and I think you only have the pH or something. I'm not entirely sure.
because it's asking from pH.
2 OH. It just looks. The number looks a little small. I was expecting like a times 10 to the 12.
Yeah. But wait, Mr. Mufo,
Because pH is
what would be the sig fig?
right.
The first one.
Okay, how many sig figs are in that number? That's a regular number. It's not like so it's for that one. But how many sig figs are in that?
And that's number 2. But so this would have the 4.00.
4 point. If you want that to have 3 sig figs, you need 4.0000. Yeah.
And this one 2.
Yeah.
And this one 2.
Yeah.
Okay.
Yeah.
I have.
Oh, this is gonna be on our best. We'll start out with 2.
No.
So the first one.
You test your. Hold it. You test your quiz. This is the quiz is JK. This is
JP's will be like,
conjugations, definition, one has a table, and you see everything the other. What conducts what goes in the other.
I have a question. Would like a salt always be more conductive than acid or
Not necessarily. Yeah, if the salt has now that we've done, solubility.
Yeah, this. Oh no, this was not my final answer. This was.
This is the stronger acid, so we
I don't know the number anymore.
That's right. Oh, both of them.
both of them are this is stronger.
Yeah. And that is a
And
completely
this
soluble.
one.
Is that why
So if it's
Yeah, because it's completely soluble. It's not it's equally strong.
so we have to use both solubility and how do we tell for salt? There's like
You're
Should also be 2 sig
you
figs.
can look it up in your solubility table.
So showing you one last
Because it tells you, like, any sodium.
oh yeah, and if it's a low solubility.
Then, if you are so complete, it will be full of weak. But we don't give you ones where you have to go with a weak acid.
Here, this is a pH.
So then
Oh,
you
you
give
have
us
to
always
show
So the givens would always just be the solid.
Yeah, those will be soluble. Or they'll give you a bunch of strong acid and a low solubility salt. So then you go, oh,
This
oh,
one also gives us 2. And here we all again are
Do that as a one.
pH. So then we can't go up here.
Oh yeah, that makes sense.
are you doing these?
I say that.
And then
Which one are
here
you?
it gives us a pH. So this is also.
Oh, it's up there.
And here we have a normal number.
Oh, here.
Yeah.
Oh, he's not quite done.
It's a normal number.
Oh, absolutely. You guys done? Yeah. Excellent.
This one.
What time? 8:45. What time is class? Thursday. 9:45. 7 questions, 14 minutes, 20 minutes. 9:10. I want to be heading. If you're done, double check your sig figs.
Go to there.
Which are the estimates? This one, this one, and this one. Oh, yeah, so B, H2T, H2.
Nice, is that your number? I think you're missing
Sig figs?
No, like times 10 to the sun. It looks like a pH, it doesn't look like a concentration. Molarity of 0.13.
Yeah, so this is, that's 3, but it's an all also.
10 to the minus 11. You might be using a modified calculator for this.
So right now we only
Show me
have.
how you do that.
I forgot my password on my desk. And
Oh, okay.
I used my phone password.
How many 6
Well,
I guess I forgot the 10 to the minus 4.
yeah, if you turn your phone sideways, I'll give you a full sighted indication. Hold it. Same for yours. Whose is this one? Anybody here? The 8.32 seems quite high. Because we don't have concentrations of like 8 molar for bases or acids, that's really high. I suspect you're missing a times 10 to the something. Yeah, so that should give you something times 10 to the minus 11. Or 10 to the 11, right? Yeah.
It's the 10 to the negative.
Well, it's also a matter of, does your calculator know what you're doing? There, times 10 to the minus 12. But you're allowed to go late
Finally.
if you're writing a, So you just tell your teacher, Mr. Neufeld has me back, it's all his fault.
Will this be two? Will this be 2 sig figs?
No, no treat. Regular number is 3, because it's a regular number, it's not a so only P, like only pH and pOH, because they're laws.
So it would be,
We have that, right? We don't have to.
they wouldn't be miles, it would be 4.000.
Well, this number has 3, and so for this one to have 3, you would have. Okay. I think, as far as I can tell, everybody got there. By hook or by crook. Okay. I think. Yeah.
Can I have the 2 cards that I had trouble with?
There's nothing higher than that. You mean the previous slide?
How is that shown?
This one? That's just all the same formulas we put down below.
Yeah, I just filled them up. So I was just gonna write it.
Okay. Okay. Your attention. Okay. Andrew. Since everybody has the work around them, make sure you have a copy of the work, but I am going to go through the sig figs, and then I'll formally define the sig figs next. If we have 1.00 times 10 to the minus 4, how many sig figs is that number? I've heard 2 answers. Andrew? Gleb? Put that down for a moment. If you have 1.00 times 10 to the minus 4, how many sig figs is that? 3. Andrew? Gleb? How many sig figs is that number, Andrew?
That's 2.
No.
3.
3. That's not a logarithm, it's not a pH, it's not a pOH, so that we just count that the normal way, that's 3 sig figs. Which means if we want our answer, the pH is equal to 4, how many zeros do we have to have? 3. So that is a pH of 4.000. Calculate the pH from OH minus, how many sig figs are in this number?
2.
2. So what is it, 11.78? So that has 2 sig figs. Yes.
Why is it 4, 6, 3, 6?
Because
That was
this is 3 sig figs, and that has no sig figs.
why?
Anything before the decimal doesn't count. I'm going to do it next. I'll define it next. For logarithms. Okay? So similarly, how many sig figs does this number have?
Has two.
2. 2 sig figs because it's a logarithm. The ones in the front don't count. So we calculate the concentration of H plus. What did we get for 3? 8 point. We only need 2 sig figs. So it is 8.1 times 10 to the minus 2. Now, I think I mentioned at the beginning of the year, when we mark like a major test, all the chemistry teachers do this. We only mark sig figs in one question. We pick the question, we'll mark that question, we'll minus that half if we get it wrong. We don't really mark it anywhere else unless you do something very, very strange with your sig figs in other places. But we're going to pick a logarithm question because it's the only new thing you've learned in terms of sig figs. So if you're a logarithm, numbers before the decimal don't count. They only count after the decimal.
It's not minus 2, it's 93.
It's not 92, it's 93.
Minus 2.
Minus 2? Minus 3. My eyes can't read from that far away. Excellent. Calculate the concentration of OH minus. Similarly, this has 2 sig figs. So we would get as our final answer, what was number 4? Where can I find someone? 8.32 times 10 to the minus 12, so 8.3. Gleb, Andrew, can you put that away? We have stuff we're doing. Put the laptop down.
I already did that.
Good, good. I'm also going over it with sig figs.
I got it right.
Excellent. Put that away. Okay. 4 sig figs to explain why we do it in that particular strange way. If we make this concentration of H0 plus, make this side the pH. If we have a number such as 1.00 times 10, I'm going to color it, 1.00 times 10 to the minus 7, as a pH in your head, what is that equal to? 7. Josh, Sam, can you put the laptop away? Notes up. It's 7, but we need to put in the sig figs, so we've got 3 sig figs, so that becomes the 0.000. This number had no sig figs. And when you take the logarithm of something, that part of it became that part of it. If it didn't have sig figs before, it shouldn't have sig figs after. It was not, we didn't count 1, 2, 3, and then 4. It was just 1, 2, 3. This just gave us the scale of the number. And so this, a logarithm puts the scale of the number before the decimal. So that's why it doesn't count. This only is true for logarithms. When you do mathematical operations on numbers so that they're represented as something else, their sig fig placement might change. If you're just using regular measurements, it works the way it always has been in the past. So if we have something like 0.0816 molar, calculate the pH to the correct number of sig figs. Samuel, what is the pH of 0.0816? And Josh, can you fold your laptop down, put it away?
I don't have that calculation.
Sam, I'll grab you for the next one because I'm going to give another example right away. Why don't I ask for this one? Ashley, log of 0.0816. 1.088. How many sig figs does this number have? It has 3. All the numbers after the decimal count. Because it's no longer about the size of it. We have done that before the decimal, so that is actually 3 sig figs. Now, I just told you something was different from all the other rules. Anybody's question? Okay. Do 1.34 times 10 to the minus 13. What is that in terms of its pH? Samuel.
12.87.
12.87. How many sig figs does this number have?
Well, 2 that are going to be used for the pH.
No. This is 3.
Yeah.
3 sig figs. So this column has the same rules you've always learned since Chemistry 11. This is the one that's ruled. So this has sig figs. How many sig figs does this number have?
Oh,
2. So we need. What's the next number on the cap? 3. There you go. Technically speaking, if I tell you that something is neutral and has a pH of 7, how many sig figs does that number have? 0. It's all telling you the pH is almost a qualitative observation, because we know it's neutral, but it's like plus or minus 10 or 100. We don't really know. We're only talking about the scale. We're not talking about the actual value that it is. The actual value is in there. So 7.1. Neutral, when it's plus or minus amount that's 10 times larger than it, isn't that much of a useful number. Okay. SROH2. Let's do a couple more. I'll put you into new groups. Erase the old work. Okay. Grab your new people. And do the next 2. You're doing those 2.
strong base because it has.
Strong base.
Yeah, it's a strong base. So it goes to completion.
Wait, is that a strong base? Yeah, is that a strong base?
Anything with hydroxide is. What it is. We assume they all are. If you go up in chemistry, you'll see that people will start talking about solubility, and then they'll disagree with you. But if you throw something with a lower solubility in an acid, it acts like a strong base, because it just releases the hydroxide. So
But does it release both?
yeah, it does the normal ionic thing.
So 2OH minus and SO2.
Yeah.
Okay, so we would
Normal dissociation from solubility.
Zero.
Oh, excellent.
pH 4, 6.
Hold it. Why do you have 17?
That's only for
Average.
Oh, you're right, so it'd be 13.
And we would want to know the pH. So we, I would do this. I would negative log
Divide it into.
POS.
Mr. Newfeld, does the SR matter?
It does it? Is it an integral part of this calculation, or is it a spectator ion?
It's a spectator
We
round.
totally.
However,
That
does what it does in solution,
0.
take a look around, maybe what other groups are doing. Weirdly, on this side,
From there.
Hey, I'm never gonna bring this to you unless I do it now.
Huh? Oh my God,
From Africa.
thank you.
Yeah, you're welcome.
Hot.
Name,
Honey.
that is, I was telling you. Anyway, I keep meaning to bring it to you, and then I was like, I'm bringing it today, you're so welcome. Ah, see you later.
Don't forget your solubility rules. Ah, excellent. Because it dissociates.
No.
How many hydroxide?
Yeah, that's what I was saying. I'm like, there's an easier way to do this.
Don't forget your solubility rules
We had
from the previous unit.
6 in the beginning, right?
Or your Chem 11, what does that do in solution?
13. And now 3 6.
Same with,
We need K.
what will it do in solution? Will it divide or multiply?
So that would be a strong
If you write the like side of it and then
Oh, we're at the equation that doesn't change. The chemical equation? Show me what you see. Sure it changed.
Oh.
It doubled.
I did know there was
It doubled. You went 2 hydroxide. So if that's 0.232, what's the other one? There you go, there you go. Nope, just listen to those two. You've got those two. Follow me over. See what you got. 464 becomes 0.333. That makes sense. Extremely basic.
Can you check the
And that gives you a really high field. This is just this is like not wearing your.
I don't think it's right.
And the second one, so you got 0.67. You use the KW.
It should be
Oh,
three.
dot
Yeah.
DOH.
3-0.
Straight from there, and is that all I asked you? Oh, yeah, that's all I asked. Hold it. You got 7.3?
This sounds about 2.5.
Times 10 by what?
Oh.
There's no way one times 10 to the minus 14 divided by 0.137 wouldn't give you. Oh, that I don't know. I wouldn't give you 2.
Yeah, because they're both on the not the
How did you get times 10 to the?
I looked at them because they thought it was gonna be it.
We got to
Okay.
Because I was gonna be like,
Wait, y'all got 13 on the block, that's good. Times 10 to the minus 14.
Yeah, no, I wish it was 3.
So what was the first one? 0.3.
yeah, I thought that was you. I was like, someone's impatient.
And Nicholas, what did you get for 3?
7.30 times 10 to the negative 14.
That could be about 6 or 7.
Wait, Mr. Neufeld.
Yeah,
That's not. That's a middle school.
that's
0.33. The final is 13.667.
Oh, is that the middle of the calculation?
Yeah.
Oh, they did that too. Sorry.
How do y'all know that?
That is correct.
How do y'all know that?
I was reading it from here. Right. It would help if I put down what I'm doing. Okay.
Well, we think because there's no coefficients, there's no need to change it because you're saying.
Oh, yeah, yeah. I thought, don't you still have to use, that's why I don't know how to use the negative log of 0.5.
You may have a seat. Pull out your calculator. Pull out your pencil. Put your books away. I will hand you a old data table.
As long as you know.
Oh,
What's a conjugate?
No, buddy, I don't want to come.
Do you have one?
Yeah.
There you
Do you have an
go.
extra calculator by chance?
Pardon?
Do you have an extra calculator by chance?
I will see if I do. Put everything away. Yeah, no. That's on snap spot. Yeah.
Do we need a pencil? Try to hold. Try to hold.
You should use a pencil always. What kind of strange, insane person would use a pen for
I would.
pens are for English. I mean, I'm not gonna stop you, but if you have to erase, say, a bubble, that won't happen. Please put everything away. Put away your data tables. Bring your data tables.
It's like, is this what it would take?
How's the old one?
Like the best way you can.
How many questions have we?
7. Oh, that's pretty sad, man.
Wait, why do we?
What? Yeah, no, put it away. You could have written stuff on it. Yeah. Also, please spread out. Move to other tables or move your desks away. Medina, Tia, Josh, Ella, Sam, Andrew, Casey, Nicholas, Ted,
It's not April.
Glenn,
I thought we were done.
Ashley, Max. And where did I put down the No yawning.